The scientific method is basically observing nature and being able to replicate those observations and establish causal relationships between one thing and another. What is the thinking process except observing something and figuring out what the causal relationships are? All right? Why use a thinking process? Well, Socrates said that the unexamined life is not really worth living. So what we're doing with the thinking process is we are examining our lives and our environments, and we're asking the question, first of all, why should we change? Why not just keep doing the same thing? And the second question is, well, if we decide we need to change, what is it we're going to change? And how does it relate to other things? The third question is, if we decide that we're going to change, what is going to be the shape of that change? What will we change to? And fourth, how to cause that change to happen. If you always do what you've always done, you'll always get the same results. Okay. So, what is the thinking process? It's a set of 5 integrated logic trees to identify first what is expected, what to change to, and how to cause the change to happen. Now, the thinking process roadmap looks something like this. It starts with a goal tree, which we use to determine what is expected of our systems. What should be the benchmark of performance that tells us that we're succeeding if we accomplish it? That's the basis, or the measuring stick against which we look at reality and say, in what ways are we not measuring up? In what ways are we failing to achieve this benchmark? And the outcome of that is a critical root cause that tells us we are failing to do this and it is producing these undesirable effects. The evaporating cloud is used to help resolve conflict issues surrounding change. Why? Because change is not usually as simple as saying, oh, well, I know that I need to fix this, we'll just change it. At some point, it becomes difficult. There will be people who will push back. And as a result, you need to be able to resolve the conflicts that will stagnate change. Once you have figured out how to do that and have figured out what your solution is, or what your solution ought to be, you go to the future reality tree, which is a way of bench testing your solution logically. In other words, you're wargaming to say, if we do this, what can we expect the results to be? Can we logically prove that our changes are going to lead to the effects that we want? And once you have verified and validated the solution that you developed in the process of moving from current reality tree to evaporating cloud, then you're in a position to say, all right, now how do we execute? Now, one of the things that you don't see on this diagram that the future reality tree is also designed to do is what I call contingency planning, and I do that because of my military background, but most people will refer to it as risk management. In other words, where could this go wrong, and where could we get into deeper trouble than we're in now? This is a formal part of the future reality tree that's designed to keep you out of trouble. Okay, there are 2 types of logic, if you will, that govern all of these trees. 3 of these trees, the goal tree, the evaporating cloud, and the prerequisite tree, are what we refer to as necessity-based trees. You start with the ultimate outcome and you read it from top to bottom. In order to have the goal, we must satisfy the critical success factor. In order to do that, we must achieve the necessary condition, and so forth with all of these things. Okay? And this is the concept of necessary but not sufficient. and you'll internalize this a little more as we go along. To that extent, the necessity trees are more like flowcharts than they are logic trees. But there are some logical rules that you have to apply, and that have to do with the categories, which we'll talk about. Two of the trees, the ones that are the sexiest, are the current reality and the future reality trees, and these are the ones that actually enable you to identify what the system problem is and to bench test a solution. These are what we referred to as what we are sufficiency trees, because we read these from the bottom up. If this cause, then that effect. If that effect, then the next effect, and so forth. And they follow a very rigorous prescribed set of logical rules that we will get into more detail on tomorrow. This is what keeps the tree from being false or invalid or a figment of somebody's imagination. It keeps you out of trouble. And one of the things I have discovered in talking to and seeing the people who have been through the thinking processes as offered by others is they don't put near the emphasis on the categories of legitimate reservation as they need to. So I am going to spend an extraordinary amount of time tomorrow working on these rules, because I want you to internalize these rules. These are the things that are going to keep you out of trouble in building your trees, number one. Number two is they're going to make the construction of the trees go much quicker if you know them.